Hello guys, welcome back to the Maths Club. This is Paul Ayog, your mathematics instructor. Today I'm going to be handling a past IB mathematics question on application and interpretation higher level. This is a question that has to do with finding Eigen vector and Eigen values when given a matrix. So let's dive directly into the question. So it says, given the matrix M equal to 3, -2, -4, 1, find A, the eigenvalues, and B, eigenvector. There's a third part to this question, and that is has to do with for us to find the PGP inverse matrix. So I'm going to be handling that in my next video because I don't want this video to be too long. So what is the first thing that we do in finding eigenvectors and eigenvalues? What is the first thing that we do? We know that when we should recall that the identity matrix I is 1, 0, 0, 1 for a dimension matrix like this, because this is a matrix in a 2 by 2 matrix. So the identity matrix is I equal to this. And we also know that for us to find the eigenvalues, we begin by saying that let eigenvalue be lambda, a certain lambda. We are going to say the absolute value of the matrix M minus lambda that multiplied by our identity matrix should be equal to 0. So we have absolute value of 3, -2, -4, 1 minus lambda multiplied by our 1, 0, 0, 1 should be equal to 0. So when we resolve what is inside our absolute value sign, when we resolve this, we are going to have 3 minus lambda as this entry. Then this entry will become negative lambda multiplied by 0 is 0. So this entry will be this, will be -2. -4, negative lambda multiplied by 0 is 0. So here will be -4. Negative lambda multiplied by y is negative lambda. So this entry will be 1 minus lambda. Absolute value is equal to 0. So what is the magnitude of a 2 by 2 matrix? Major diagonal. We multiply major diagonal, which is 3 minus lambda multiplied by 1 minus lambda. That's the major diagonal. Minus, we multiply also the minor diagonal, -4 and -2. All this should be equal to 0. So when we expand here, we are going to have 3 minus 3 lambda minus lambda plus lambda squared. -4 multiplied by -2 is 8, and this will give us -8 equal to 0. So you already see that this is a quadratic because the highest power is 2. So I'm going to have lambda squared. When we simplify these two guys, it gives us -4 lambda 3 -8 will give us -5 equal to 0. Then when we factorize this quadratic, we are going to have lambda -5 into lambda plus 1 equal to 0. So we have lambda, when we solve these two equations, these two brackets, we're going to have lambda equal to -1 and lambda given as 5. So let's call lambda 1 as -1 and we call lambda 2 as 5. So these are the two eigenvalues that we have obtained. So if we can call this first part as sub A, we are going to proceed with sub B, which is the second part, finding the eigenvectors. So the eigenvalues are -1 and 5. So for the eigenvectors, we can say let V1 be the eigenvector x1, x2, and V2 be the second eigenvector, which is I can call y1 and y2. So it means I will use the first eigenvalue to get the first eigenvector and the second eigenvalue to get the second eigenvector. So how do we proceed? We say for lambda equal to 1, I'm going to have the first eigenvector given as, this is the matrix I'm going to use. I'm going to use this matrix. This matrix that came as a simplification of these guys in here. So this is what I'm going to use. So I'm going to have 3 minus lambda 1, -2, -4, 1 minus lambda 1, all that multiplied by my eigenvector V1 should be equal to 0, 0. So I'm going to have 3. My lambda 1 is negative 1, sorry. My lambda 1 is negative 1, so lambda 1 is negative 1. So when I plug in negative 1 here, I'm going to have 4 here. This one remains negative 2, negative 4. If I plug in negative 1 here, I'm going to have 2 here. So all this multiplied by the first eigenvector, which is x1, x2, should be equal to 0, 0. So how do you multiply out matrices? Row multiply with column. So we have 4x1 minus 2x2 should be equal to 0. I can call this one equation 1. Then this second row also multiplies. We have negative 4x1 plus 2x2 should be equal to 0. So I will not call this one equation 2 because if you look at it, equation 1 and equation 2 are the same. So if I multiplied all through by negative 1, I will have 4x1 negative 2x2 equal to 0, which is just the same as equation 1. So I will say using equation 1, I will divide all through by, I will say 4x1 will be equal to 2x2. So divide all through by 4, I will have x1 all over x2 will be equal to 2 all over 4. So I divided by x2, I divided here by 4. So x1 is to x2. Will actually be, this one will give us 1. When we simplify, here will be 1, here will be 2. So the 1 is to 2. So you see that the eigenvector v1 will actually be 1, 2. So that's my first eigenvector, which is 1, 2. Then I will also say for lambda 2, which is equal to 5. For lambda 2 equal to 5, I will have the same matrix. Like I said, this matrix here, the last matrix that we had here, which will be 3 minus lambda 2. We have negative 2 here, negative 4, 1 minus lambda 2, all that multiplied by v2 should be equal to 0, 0. So when I do the same, when I plug in 5 here everywhere for lambda 2, I'm going to have 3 minus 5, which will be negative 2. Here will be negative 2, negative 4. I plug in 5 here, here will still be negative 4. All that multiplied by my v2, which is given as y1, as y2, which I had as y1 and y2, should be equal to 0, 0. So row multiplies with column, I'm going to have negative 2y1. This one multiplied with this negative 2y2 should be equal to 0, which I can call equation 2. Now, when I multiply this row also, it will give me the same equation like equation 1. That's why there's no need multiplying this last row. So I'm saying that this last row, negative 4 multiplied with these guys, it will still give me the same like this, my equation 2. So there's no need multiplying that out. So from here, I see that negative 2 is a common factor. Dividing all through, I'll have y1 plus y2 should be equal to 0. From there, y1 should be equal to negative y2. So you see that the coefficient here is 1, the coefficient here is negative 1. It implies that y1 is to y2 will just be 1 is to negative 1. 1 is to negative 1. So it means my v2 eigenvector will just be 1, negative 1. Because if you look at it very well, you see that the coefficient here is 1, the coefficient here is negative 1. So 1 unit of this corresponds to negative 1 unit of this other guy. That is why the eigenvector is 1, negative 1. So ladies and gentlemen, my next video will be the third part of this question, which is finding the PDP inverse. So see you in my next video.